Welcome to Chapter 2, Section 2.3. We're going to discuss proportions, and the most important thing probably we're going to talk about with regard to proportions is the ratio proportion method. It's one of the most frequently used methods for calculating drug doses in the pharmacy, and we can use this method anytime one ratio is complete and the other has a missing component. So in other words, if we know 3 of the 4 values, we can solve for the missing value. When we set up ratios, it's important that the numbers remain in the correct ratio and the numbers have the correct units of measurement. So if we look at the example on page 45, example 2.3.2, we'll see that a drug is available as 250 milligrams per 5 ml. And the what we're trying to find are how many milliliters represent a dose of 375 milligrams. So we can see that we've got milligrams over here, but we are missing our 4th variable, which is going to be milliliters. So that's going to be X. So when we set up our proportion, I like to put X on the left side. The desired dose is 375 milligrams. So that's always going to go underneath what we're solving for. And then we already have the available dose. So 5 ml and 250 milligrams. Now it's important to remember why I put 5 ml on the top. It's because the milliliters are on the top in the numerator. You always want to make sure that your units of measurement match. So you want to have milliliters. If you've got milliliters on this side, you want to have milliliters on this side. And we have milligrams in both of the denominators. You want to make sure that those are always the same. So what we want to do is isolate the variable. So to do that, we are going to multiply 375 milligrams on the top over here, and also on the top over here. This is going to cancel out. This is going to cancel out the milligrams, and then we're going to multiply by that. So if we rewrite it, 5 times 375 is 1875, and we have milliliters because that's the only unit of measurement left. This canceled out and this canceled out, so now we have over 250. Now right now we have an improper fraction. We want to reduce that, but by doing that we want to take 1875 and divide it by 250. So if we do that, we know that that comes out to 7.5. Therefore, X equals 7.5 milliliters. So a really easy way to check this too, if we rewrite it here, 7.5, if you multiply by that, and you multiply by that, they are going to, of course, equal each other. So if we turn to page 49, let's look at a couple of the problem sets. Okay, solve for X for each of the following ratios. Round your answers to the nearest hundredth when necessary. So let's look at number 1. We have X over 10 equals 20 over 40. So we are going to multiply by 10. These two cancel out. Multiply by 10. So if we isolate the variable, we know that 20 times 10 is 200 over 40. And if you divide these two to get rid of your improper fraction, X is going to equal 5. All right, number 2, X over 0.6 equals 0.8 over 6.12. So same thing, multiply by 0.6, those two cancel out. Multiply by 0.6. This isolates our variable. 0.8 times 0.6 is 0.48 divided by 6.12. If we take the numerator divided by the denominator, X is going to equal 0.0 7843, and of course it says we want to round to the nearest hundredth, which we know the hundredth section is right here where the 7 is, and we have an 8, so we are going to round up to 0.08. Whoops. Equals x. Okay, so pretty straightforward solving for x. Let's look at a couple of different ones where the wording is changed. Let's look at number 16. Set up proportions and solve for x to answer the following questions. Round your answers to the 100th place. 72 is what percent of 254? Okay, so it doesn't have a percent, it just has two numbers. So we're going to be solving for x because x is the percent that we're looking for. X is always going to be a percentage of a 100%. So we know that we're going to have x over 100. And 72 is what percent of 254? So 254 is going to go on the bottom. Same thing, we're going to put 100 on the top to cancel these two out and isolate the variable. Therefore, we're going to multiply by 100 on this side as well. So 100 times 72 is 7,200 over 254. If we divide the numerator by the denominator, that is going to give us an answer, and I don't even have the answer here. 1 second. $28.3464. And again, it says round to the nearest hundredth, and it's a 6, so we know we're going to round up to 28.35. Okay, let's look at the problems that are dealing with converting to kilograms and pounds. Number 31. We're going to convert 6.3 pounds to kilograms. So same thing, we're going to set up a proportion. The thing that we're solving for, x, is going to be kilograms, the variable that we don't know, and our known weight is 6.3 pounds, and we know that 1 kilogram is equal to 2.2 pounds. So again, 6.3 to cancel those out, 6.3. The pounds are going to cancel out. We're going to multiply 6.3 times 1, which is 6.3, over 2.2. So we've isolated x. 6.3 divided by 2.2 is going to give us 2.863, and we want to round our answer to the 10th place, which is going to be where the 8 is located, and that is a 6, so we know we're going to round up. So x equals 2.9 kilograms, because that's what we were solving for. Okay, let's do one more, number 32. 15 pounds equals x kilograms. So we know that x is going to be what we are solving for, 15 pounds. And we know that 1 kilogram, again, is equal to 2.2 pounds. That's going to be a constant throughout your pharmacy career. So multiply by 15 pounds to cancel these two out over here. Same thing over here. The pounds cancel. 15 times 1. We can see the variables isolated, so let's rewrite this. 15 times 1 is 15 over 2.2. And if we divide these two out, that comes out to 6.818. But remember, we're rounding to the nearest tenth, and we have a 1 next to that, so we're going to round down to 6.8, and we're solving for kilograms. 6.8 kilograms. All right, let's look at one of the application problems, number 41. Set up a proportion using x as the unknown and solve the following. Explain in your own words how you set up your proportion. A drug is available as 50 milligrams per milliliter. The order calls for 100 milligrams. How many milliliters will you prepare? So the most important thing when you're looking at the question is, what are we trying to find? And in this case, we're trying to find milliliters. So we know that's going to be x. X is going to be milliliters. So we know that the desired dose is 100. That's going to go on the bottom, and that's milligrams. And milliliters, and that's 1. It just says milliliters. That's 1 is implied. You can write it if you like. So checking to make sure we have our proportion set up. Are our units of measure the same? Yes, they are. So we want to go ahead and multiply by 100. Whoops, that should be on the top. To cancel those out, same thing over here. Milligrams are going to cancel out. Isolate our variable and rewrite the equation. You don't have to rewrite the equation. I'm just doing that to simplify for you guys to make it easier to see. 100 divided by 50 is 2. So x equals 2, and again, we're solving for milliliters. Most important thing to remember, again, when you're reading these problems, don't let them overwhelm you as you read them. Usually, you're going to know what you're trying to solve for when you're reading the last sentence, what you're looking for, how many milliliters, how many tablets, so you'll know what your x is going to be. Looking at number 42, Maxicillin is available as a 125 milligram tablet. How many tablets are needed to give a dose of 375 milligrams? So this is the desired dose, and what are we solving for? How many tablets? We're solving for tabs, number of tabs. So x equals tabs over our available dose, or I'm sorry, our desired dose, 375. And we know that 1 tab is equal to 125 milligrams. So our units of measure match up. Yes, they do. So 375 milligrams to cancel out. Our milligrams are going to cancel out. Isolating x, 375 over 125, and 375 divided by 125 is 3. So x equals 3 tablets needed for the proper dose. Let's do one more. Number 43. Silkamycin is available as a concentration of 20 milligrams per mil. How many milliliters are needed to prepare a foot soak that contains 300 milligrams? So we're looking for how many milliliters. So milliliters is what we are trying to find. That's going to be our unknown, our x. The desired dose is 300 milligrams. And we know it's available as 20 milligrams per milliliter. And checking to make sure our units of measure match up. Yes, they do. So we're going to take 300 milligrams to cancel. And again on this side, the milligrams cancel out. 300 times 1 is 300 over 20. This isolates our variable. So I'm going to rewrite it over here. 300 divided by 20 is 15. So we know x equals 15 milliliters. And don't forget to write your unit of measure when you're answering the question. Don't just put x equals 15. Let them know. Remember, we're solving for milliliters, so always make sure your answer reflects that. Okay, so go ahead and work on the rest of the questions on your own. If you have any questions, feel free to post those to the Q&A or the virtual office discussion thread.